Question 2. Following charges are located inside a submarine. Okay, so we'll draw our sub. There's a positive 5 microcoulomb. There's a negative 9 microcoulomb. A 27 microcoulomb. And a negative 84 microcoulomb. Okay. All located within the sub. Calculate the net electric flux through the hull of the submarine. Okay, so back to Gauss's law, since we're dealing with flux. Flux would be equal to the integral E dot dA, which doesn't help us too much here because we don't have an electric field. We don't know the area of the submarine, so we can use the second half of this, which is the charge enclosed over epsilon naught. So all we have to do here, I need to know how much charge is enclosed. So if you take 27, positive 27, you add 5 to it, then you minus 9, then you minus 84, you should end up with a negative 61 microcoulombs of charge when all of these are added together. Okay, that gets set over epsilon naught. Remember, epsilon naught is simply 8.85 times 10 to the negative 12th. Okay, so we have negative 61 times 10 to the negative 6th over 8.85 times 10 to the negative 12th. If we do that out, we should get around negative 6.9 million. So in the answer here I have 6,892,655. And it's flux once again, which means we're going to have electric field in an area, so we'll have newtons meters squared over coulombs. And that's our answer for part A. Okay. Being the overall charge inside was negative, it just means that the flux is negative. More electric field is being pulled inside than what is being released. Okay. For part B to the question, is the number of electric field lines leaving the submarine greater than, equal to, or less than the number entering it? So that's what we just answered. Okay. Being that the field lines leaving, the positive ones giving everything away, are less than the number that's coming in, the negative charges taking everything for themselves, the number of field lines entering must be less than the number, the number of field lines leaving must be less than the number of field lines that are entering. Okay, so we have many more coming in than we have going out.